Hi there, it's Jason Gorman from Codemanship with another video diary entry. If you're finding these videos useful or enjoyable, please like and subscribe to this channel and ring the bell for notifications. Okay, so today's video I'm going to be talking a little bit about this idea of a clean check-in, basically, a clean check-in. Now this is a pattern that is mentioned in Beck's excellent book, Test-Driven Development by Example, highly recommended. And it's a very, very simple idea, basically. If we're going to commit code, basically, we want to be sure that code works. So before we commit it, we make sure we see all the tests pass first. It's as simple as that. Now, I've got a little sample project set up here with a continuous integration workflow set up on GitHub Actions that will build and then test my little project every time I push to it. And the goal here, essentially, the discipline of continuous integration, is to make sure that whatever we're pushing to that main branch, to the trunk, as many people call it, works, that it's potentially shippable. It's the foundation of this practice called continuous delivery, which is our code is always shippable, which implies it must always be working. So we don't push code that we don't know, unless we're pretty confident that it works. In other words, unless we've seen it pass the test. And on our side, on the client side of that little workflow, we don't commit code unless we've seen it pass the tests. Now, this is a habit that developers can get into. I find it very difficult to commit code without seeing the tests pass. And I want to sort of demonstrate it, first of all, doing it the hard way. So we're just going to do it the old-fashioned way, using the Git client on my desktop. So here's my little Mars rover project. Don't worry too much about what this is about, but we've got a Mars rover and we can turn it to the right. So we can make it turn from north to east, east to south so far. And we want to add another test to that. So let's do a little bit of work here. It turns right from south to west. Oops. South to west there. Assert first and work backwards. So this is all just TDD, the way you would normally do it. So this is our turned rover. We're doing this in the immutable functional style. And we're expecting the final direction to be west after we've turned it from south. Okay, working backwards. We need our turned rover. And that's the result of calling the right function with our initialized rover, which is facing south. And then finally, let's create our initial rover. And this could just be a simple data object where we set it to be facing south. Oops. Okay, so that's our test there. And I'm just going to run the test to make sure that it is failing for the right reasons. We're going to talk about that in a minute. Okay, yeah, south is not equal to west. That's what we're expecting. So let's do the simplest thing to pass this test. So if rover direction equals east, turn it south. And no, you're not working in Python, Jason. So many programming languages. Otherwise, let's make it face west. Okay. Now let's run all of our tests. So you can think of code as having two states. There's the kind of like the state where we know it's passing the test. We've made no changes to it since we run the test, and so we become confident now that this code passes its tests. If I make any changes at all to the code, even something as innocuous as that, then that second state of code, which I call the dirty state, the state where we don't know if it passes the tests, is a state in which you should never even think, you shouldn't even contemplate committing it. If you make any changes, if you edit the code at all, you need to rerun those tests before you can even consider committing that code. So let's commit that, because we know it passes the tests. So added test to turn rover right from south to west. So a nice meaningful commit message there, right? And the whole goal here is if I push this, we want to be confident that what I'm pushing here actually works. In other words, it's potentially shippable, and then we're achieving that sort of goal of continuous delivery. So let's just keep one eye on the build there. Our build said, so that's kicked off a build, that's queued up at the moment. And it's still queued. Okay, lovely. It's always the danger of doing demonstrations with the free versions of build tools, cloud-based build tools. Okay, build is in progress. So it's going to attempt to run those tests, and there we've got a green build. So what we've got sitting on that main branch, on the trunk, on the release branch, if you like, is potentially shippable. If we wanted to ship that, for example, if we wanted to automatically deploy it every time the build succeeds, or if there's a button that the customer can press that deploys it when they want, or whatever your workflow is, our goal here is to make sure that what's sitting on that main branch is working, it's shippable, and that means we shouldn't push anything that we don't know works, and therefore we shouldn't commit anything that we don't know works, hence a clean check-in. Now, this is a habit that is difficult for software developers to get into. There's a bit of discipline here that has to be built over, months and years. And so I've had some success with people who are new to TDD and people who are new to continuous integration by creating a wrapper around the Git client. So they can't get to Git directly, or at least we hope they won't use Git directly. But I've created a little Windows command file here, a little batch script called check-in. And what you'll see here is this is like the codification of a clean check-in. It will attempt to run the tests first, and only if the tests complete with a return code of 0 of success will it then attempt to commit it. If the tests fail for any reason, it won't attempt to commit it. So let's do a clean check-in first of all. Let's change something. So now my code is dirty. I've edited the code and I've not run the tests. If I try to check in with my little batch file here, let's do a check-in, and deleted blank lines. Now the tests should pass, and you'll see after the tests it does a commit. If for any reason the tests don't pass, if I attempt to commit that using my little clean check-in utility, failing test, it's a test of a failing test. Okay, it will attempt to run the test will fail, and then it doesn't attempt to check it in. So you can kind of create a barrier around, a little quality gate, if you like, for when you're doing your commits, to prevent or to reduce the risk that people are committing stuff that doesn't pass the test, that is not potentially shippable. And if we're not committing it, then we can't push it, and that's the little gatekeeper we've got there. Okay, let's just. Well, actually, that's broken, and this is going to lead me on to the next part of this demonstration, because an easy way back if my tests are failing is to do a hard reset. So it's back at passing now, and just to prove that, let's run those tests from using npm. All our tests are passing again. And this is another related workflow. It's similar in many ways to the clean check-in that's described by Kent in his book. And I believe Kent Beck himself came up with this idea of doing something that was, I think, very much along these lines. But then it was suggested that we could add a third part to that. And that's where we get into this idea of test and commit or revert. So we've got the test and commit part still as it was. But if this fails for any reason, we flip over, that's the or, we flip over to this part. In other words, if any of your tests fail, it will automatically revert the code. So if your tests pass, it will automatically commit that code. But if any tests fail, it will automatically revert it, and you will lose all of your changes. Now, at the very least, this is a very useful exercise, I think, in encouraging developers to take smaller, safer steps and keep their code working, to take less risks, basically, in between running those tests. So if they're refactoring, for example, they do smaller refactorings, safer refactorings. So I found it a really useful exercise as a trainer and as a coach. Some people are incorporating this also into their workflow. So it's kind of a test-driven development on steroids. It's clean check-in with consequences if it's not clean, that you lose your changes. And when you first try this exercise, it can be a little heartbreaking if you make too many changes and you put a lot of effort into that. And of course, the more changes you make, the more things you could be breaking. To lose all of those changes and have to start again is a little heartbreaking, but it does kind of teach you a lesson there, which is to take smaller steps. So as an exercise, I found it really useful. In terms of workflow, on production code, not so sure. I would use TCR when I'm expecting the tests to pass. So instead of running your tests, you would do TCR instead. Whenever you want to see the results of your tests, you would say, okay, let's use this TCR script. And we're just demoing TCR. And all our tests are passing. So as you'll see, it will work. That's when I'm expecting the tests to pass. And so again, if I push that, that should give us another green build. That should give us another clean check-in. And we'll go and check that in a minute. And of course, if any test fail, it will just revert it and I have to start again. So in terms of workflow, I think this is very useful if you're expecting the test to pass. I think there's one part of TDD in the way that I practice it, and a lot of people practice it, where I don't think it's appropriate, and that's when you're expecting the test to fail. So when you get that first red light, when you first see the test fail, and I believe that's a very important habit to get into, it is very beneficial, I think, or I've certainly found over the years, to make sure that before you write the code to pass the test, that the test does indeed fail when the result is wrong. So going forward, you can have confidence in that test. Doing TCR with students, what I've found is there's an element of it where they've never actually seen the test fail. And that starts to sort of wear down their confidence in the test suite. So I don't have any results on how, I have not seen TCR used on real production code at scale. So I don't know what kind of results people are getting, but it did make me I did have less confidence in my tests when I tried it. And that's an experience that I think a lot of people have reported. So I think TCR is a really useful exercise in encouraging you, one, to do clean check-ins, keep that code working. You don't commit anything that doesn't work. But also a really useful exercise in encouraging you to take smaller, safer steps to change less between running the tests, basically. But as a complete workflow, I'm not entirely convinced. You can make up your own mind and let me know in the comments whether you think TCR would work for all cases or whether it needs augmenting in some way. But certainly it is, at the very least, a very, very interesting exercise. So there you go. There's some very simple workflows that you can apply that reduce the risk of you essentially committing code that doesn't work. And in the case of TCR, can also encourage you to take smaller, safer steps. But they all lead to the same road, which is we're looking to keep this code working, basically. Our goal here is to keep the code working, to keep those builds green. And that's why clean check-ins are so important. Okay, that's all from me today. Hope you're having a good one. The sun is shining here in London, even if it is a little cold now. I will see you in the next video diary. Take care and stay safe.